Assalamu alaikum students. So in this we will discuss about uniform motion and non-uniform motion. So what is uniform motion? A body is said to be in uniform motion if it covers equal distances in equal intervals of time. The term uniform means something which happens regularly, periodically. Let's suppose if you have an object which covers say 1 kilometer in 1 hour, and in next 1 hour he moves another 1 kilometer. Again in next 1 hour he moves again 1 kilometer. That is in every interval of time. That is in 1 hour. It's covering a distance of 1 kilometer. So we say that the object is in uniform motion. If we take an example of a car, suppose the car is running on a highway where there's no obstruction at all, the smooth plain road where the car is moving. So, in that case, your car might be moving at a uniform rate, and that means for every hour it's covering the same distance. Suppose the speed of car is 40 kilometer per hour. It every hour it's covering same amount of distance. That means in every 1 hour it's covering 40 kilometer. In the next 1 hour it's again covering one more 40 kilometer, another 40 kilometer. Total it covers 80 kilometer. That means every 1 hour it's covering 40 kilometer. That is uniform motion. Now, what is non uniform motion? A body is said to be in non uniform motion if it covers unequal distances in equal intervals of time. Again, suppose you have a car, okay, and say it's covering 5 kilometer in first 1 hour. In next 1 hour, it's covering say 20 kilometer. In third hour, it's covering some 8 kilometer. That means for every interval of time, the distance which it covered is not equal. Sometimes it covers less distance, sometimes it covers more distance. And the best example for non-uniform motion is a car moving in a traffic. So when a car is in traffic, somehow it has to escape between the spaces between the vehicles, right? Therefore, a speed of car will be slowly. At first, it will be slow, and gradually, when it has smooth road, it picks up speed. So speed increases. That means when the amount of distance which is covered in is unequal in equal intervals of time, then you are having non-uniform motion. Object is having non-uniform motion. Okay. Now let's look at interpretations from different distance time graphs. So just now I told you by looking at distance time graphs, we get a lot of information, not only about speed, as I mentioned in the previous lecture, that slope of distance time graph gives speed of objects. So not only speed, we will get many other informations about the motion of an object from a distance time graph. So let's look at some scenarios where by looking at distance time graph, we can easily tell the motion of an object. So this is the first distance time graph. Distance along y-axis and time is along the x-axis. It's discussed in the previous lecture. Okay. So here I am having a straight line parallel to the time axis, right? So you see as the time increases, the distance remains the same. Say suppose the object is having a distance of say 3 kilometers. Okay. So we see distance covered is 3 kilometer for every 1 hour. Suppose in the first 1 hour it's again 3 kilometer. It's 3 kilometer. In the next second hour, okay, one more hour, it's again 3 kilometer. Okay. So it's showing that the distance covered is 3 kilometer for every interval of time. That means distance is not increasing with time. The distance is constant with time. And what does that mean? That means there is no motion involved. Because if the object is moving, in that case, there will be some distance covered, or distance covered will increase with time, right? So suppose if I am having an object that starts from this point, and suppose it covers 4 kilometer or 5 kilometer or something, okay? But when say object it's moving from this point to this point, and suppose it's covering some distance, say 3 kilometer, okay? Now if the object is even now moving, then this 3 kilometer should increase, say suppose 4 kilometer, 5 kilometer or something. But Here in graph you can see that distance is always 3 kilometer. That means object is at rest at this point. So it means in this case there is no motion, object is at rest. Okay. Now let's look at second scenario, case second. Okay, so here we have a graph like this. Okay, and so what do we see here? With increase in time, the distance is also increasing. Say in first hour, distance covered is 1 kilometer. In second 1 hour, the distance covered is again 1 kilometer. It's 2, but 2 minus 1, that is 1 kilometer. Okay, now again in the third hour, 1 hour more, distance covered is again 1 kilometer, because 3 minus 2, it would be 1 kilometer. So this is which kind of motion? As in every 1 hour, distance covered is 1 kilometer. Which kind of motion is this? This is uniform motion, because distance is covered, equal distance is covered in equal intervals of time. So this graph depicts uniform motion. Okay, because the object covers equal distances in equal intervals of time. Now let's look at third scenario. Okay, now we are third scenario in the, we are having a graph like this. Look at this graph. Here also the distance increases with time, increase in time. Here you can see time is 2 hours, distance is 1 kilometer. Okay, time is 3 hours, distance covered is 2 kilometers, and so on. Here also distance is increasing with time. What does this show? This line starts from 1. This is showing a uniform motion because distance increase with time. Okay, but this line starts from 1, not from here origin. Okay, so what happens when time increases from 0 to 1 hour? So in first 1 hour, as you can see, there is no movement of object. There is no movement of object. So this is 0. So here we are having no motion. The object is at rest for the first 1 hour. After that, the object is in uniform motion. Okay, at the first 1 hour, object is at rest. After that, object is in uniform motion. Now let's look at fourth scenario. Here, where you see that you have a curved line for distance time graph, right? What kind of motion does the object has? Here also you see the distance increases with increase in time, but distance doesn't increase linearly. If you see in the first 1 hour, the distance increases from this point to this point, right? This much is the distance covered in first 1 hour. In next 1 hour, it also again increases from this point to this point. Only this much of distance. Again in third 1 hour, you see the distance covered is more. That means for equal intervals of time, the distance covered is unequal. Sometimes more distance, sometimes less distance. And which type of motion is this? This is a non-uniform motion. So we are having a non-uniform motion because you have a curve like this. Because of this curved line, we say object has non-uniform motion. Now let us suppose if instead of this, you would have a straight line like this. You would have a straight line like this, then some curve, and then again a straight line. This shows that this portion, which is a straight line, look here, this portion, this depicts uniform motion. Then middle portion will depict the non-uniform motion, and this portion where you have a straight line, this will depict no motion because here distance remains same with time, so no motion at all. This is how we can interpret about motion of object by looking at distance time graphs, or you can say position time graphs. Thank you, students.